Okay, in the last video we had a look at generating sequences using what we call an nth term rule, which is an algebraic expression involving the letter n, and n represents the position in the sequence that we're interested in. So here are four expressions, four nth term rules. We're going to have a look at the sequences of each of these. If you'd like a little warm-up task, what you could have a go at is pausing the video and see if you can work out the first four terms of each of these sequences using these four nth term rules. So if we're looking at the first four terms, we're going to replace n with 1, then n with 2, then n with 3, and then n with 4. Have a little go. Okay, so let's now have a look at what these four rules will generate as sequences. So 3n means 3 times n. And if I'm looking at the first four terms, I'm going to be looking at the first term when n is 1. So 3 times 1 would be 3 for my first term. For my second term, I'm looking at when n is 2. So 3 times 2, that will give us 6. Looking at my third term, replace n with 3. 3 times 3 would be 9. And my fourth term, 3 times 4 would be 12. Let's have a look at the second one. So the second rule looks very similar, but there's a -1 at the end. So we're going to use the same technique. Looking at my first, second, third, and fourth terms. My first term, replacing n with 1, we're going to have 3 times 1, take away 1, which is equal to 2. Then we're going to have our second term, 3 times 2, take away 1, which is 5. Then 3 times 3, take away 1, which is 8. And then 3 times 4, take away 1, which is 11. Now, what do you notice about these two sequences? Well, hopefully, one thing you might have spotted, just grab my pen, is that firstly, the sequence above goes up in threes. 3, 6, 9, 12. But then if we look at the sequence below, to get from 2 to 5, to get from 5 to 8, to get from 8 to 11, that also goes up in threes. So both sequences go up in threes. They look a little bit different from one another, but they both have this in common. Would we have been able to identify this before even making these sequences? Well, the rules both involve a 3 in front of the letter n, and that's no coincidence, because what this is doing is 3 times a number, and 3 times a number, or specifically 3 times a whole number, like 3 times 1, 3 times 2, 3 times 3, will generate a number in the 3 times table. So if 3n is involved, we're always going to end up with a sequence that goes up in threes, just like the 3 times table. If we compare these numbers with these numbers below, sure, they both go up in threes, but can I do something to the numbers at the top to make the numbers below? And the answer is yes. If I take these numbers and I take away 1 from each of these numbers, I end up with these numbers below. So 3n makes the numbers at the top. If I take away 1 from 3n, I would get the numbers below. And of course, that is exactly what the rule tells us. The second rule is the 3n rule with 1 taken away. Let's have a look at the next two rules. So 5n. For the first term, we would have n is equal to 1. So 5 times 1 would be 5. Second term, 5 times 2, which would be 10. For the third term, we would have 5 times 3, which is 15. And then we would have 5 times 4, which is 20. For our fourth nth term, 5n plus 2, replacing n with 1 first, for our first term, we'd have 5 times 1 plus 2, which is 7. For our second term, of 5 times 2 add 2, which is 12. And then we continue and work out the next, we would have 17 and 22. What do we notice about these two? Well, these two sequences also have something in common. Looking at the first of the two, this first one is going up in fives, 5, 10, 15, 20. Likewise, the second one is also going up in fives. The numbers look different, but it's still going up in fives. So why is it going up in fives? The reason why these two sequences are going up in fives is because they both have the 5 times table involved. 5n. 5 times 1, 5 times 2, 5 times 3. That is why these two sequences go up in fives. If we look a little bit closer, this is clearly the 5 times table, 5, 10, 15, 20. What do we do to the 5 times table to make the sequence below? All the numbers in the 5 times table have had 2 added onto them. 5 add 2 makes 7, 10 add 2 makes 12, 15 add 2 makes 17, 20 add 2 makes 22. So this sequence, 7, 12, 17, 22, is the 5n sequence, the 5 times table, with 2 added on, and that's why it has the rule 5n plus 2. So why are we looking at these sequences in this much detail? Well, suppose we actually were given a sequence and we had to figure out a rule for that sequence. This is actually extremely handy because when you find rules, or sorry, when you find patterns or sequences in real life, and you had to make predictions as to what would happen in the distant future, well, you could have a look very carefully and gradually work your way up the sequence. But if you have a rule, that could actually take you to any position in the sequence that you want. Let's have a look at this in case. So here's our question. Find the nth term for the sequence 3, 7, 11, 15. So what do we notice first about this sequence? First thing we're going to do is have a look at what does this sequence go up in. This sequence, if you look very carefully, goes up in 4s. Okay? So what does that mean about our rule? What must our rule have if it goes up in 4s? The answer is it must have a 4n involved. 4n will generate the 4 times table. So what I'm going to do, I know my rule is going to have 4n. I'm now going to write out the 4 times table. 4, 8, 12, 16. And now I'm going to look very carefully and compare this sequence with the sequence that I'm given. And in fact, underneath, I'm going to write down the sequence that we want, because we want the sequence 3, 7, 11, 15. So they're not the same sequence. 4n would make the sequence 4, 8, 12, 16. We want the sequence 3, 7, 11, 15. Can you see what we need to do to the 4n sequence to make the sequence below? Hopefully you've been able to spot it. If we take away 1 from every number in the 4n sequence, we would make the numbers in our sequence. 4 take away 1 is 3, 8 take away 1 is 7, 12 take away 1 is 11, 16 take away 1 is 15. So what is our rule going to be then? Have you figured it out? So our rule has to start with 4n, but because we have to take away 1 from our 4n sequence, it has to be the sequence. It has to be the rule 4n minus 1. And we can even do a check to see if this is correct. So 4n minus 1. If I replace n with 1, 4 times 1, take away 1, that would give us 3. 4 times 2, take away 1, that would give us 7. 4 times 3, take away 1, that would give us 11. 4 times 4, take away 1, that would give us 15. So we seem to have got the correct answer. Our rule for 3, 7, 11, 15 is 4n minus 1. There's a second part to this question. Then find the 100th term. So remember that in the rule involving the nth term, n is equal to our position number. So for our 100th term, that tells us that n has got to equal the number 100. So we've got our rule, 4n minus 1. So now let's just replace n with 100. So 4 times 100, take away 1. So 100 is the number that replaced n. That gives us the value 399. What does that mean? That means that our sequence 3, 7, 11, 15 going up in fours keeps on going up in fours. Eventually we'll get to the number 399, which is in the 100th position. And that is exactly why nth terms are super useful, because they can give us a term in any position that we want. Right, we spoke quite a lot there. Let's have a look at another example, and let's try and go through the steps in a way which you can apply in the next task. So find the nth term for the following sequence: 9, 15, 21, 27. Try and recall what the first thing we looked at was in determining the rule. The first thing we looked at is the pattern in this sequence. So 9 to 15 to 21 to 27, this sequence is going up in sixes. So we're going to have a look at the 6n sequence. So our rule has to have 6n involved. So I'm going to write down 6n. If it was going up in sevens, then we'd write down 7n. If it went up in tens, we'd write down 10n. So what does the 6n sequence look like? Well, 6n is just the 6 times table. 6 times 1, 6 times 2, 6 times 3, and so on. So let's just write down the 6 times table. It's the first 4 terms. Why 4 terms? Well, our sequence, if you have a look, has 4 terms as well. So that's why I've just written the first 4 terms. Okay, so we've got 6, 12, 18, 24. Now let's compare this sequence to the sequence that we want. I'm going to write the sequence that we want underneath. So our sequence starts with 9, then it's 15, then 21, and then 27. Okay, so how do these compare? Well, they both go up in sixes, as was our plan. That's why our rule has 6n involved. how do we get from the 6n sequence to our sequence? Can you figure it out? To get from the 6n sequence to the sequence below, every number must have 3 added on. So we need this sequence plus an extra 3. So what does that mean for our rule then? Well, our rule definitely involves 6n, but it has to be the 6n sequence plus an extra 3. So our rule generates the sequence 9, 15, 21, 27 is the rule 6n plus 3. So I've got the rule now, 9, 15, 21, 27. We can do a little check. So for our first term, we replace n with 1. 6 times 1 add 3 makes 9. So that one works out. For our second term, 6 times 2 add 3 makes 15. And that's what we have. So that one checks out. And we can keep on checking, and hopefully we'll find that the other numbers work as well. Next part of our question, find the 100th term. So remember, our 100th term is when we replace our letter n with 100. Remember, n represents the position number. So we're going to use our rule of 6n plus 3, and we're going to replace n with 100. So instead of 6 times n plus 3, we have 6 times 100 plus 3. 6 times 100 plus 3 is 603. What does that mean? That means that our sequence 9, 15, 21, 27, as it goes up in sixes, will keep on going up. Eventually, we'll get to the 100th number in the sequence, and the 100th number will be 603. I'd now like you to pause the video and have a go at task number 1. Find the nth term and then the 100th term for the following sequences. Okay, we're going to have a look at one more example, a little bit trickier this one. Looks pretty similar, but notice how there are some negatives involved. Let's just see how that might affect our answer. So, find the nth term for the sequence, -1, -4, -7, -10, and so on and so forth, then find the 100th term. So we're going to follow our routine as before. Nothing's going to change. Just because the numbers look negative doesn't mean we have to change our approach. So how do we get from one term to the next? Well, what's important to recognize here is that we're not going up by an amount. We're actually going down by an amount. We're going deeper and deeper into the negatives. So rather than just saying that there's a gap of 3 between our numbers, we have to make sure it's clear that we're going down by 3. So we're taking away 3 from one number to the next. Okay. Now, ordinarily, we'd say, well, if there's a gap of 3, we have to look at the 3n sequence. But the problem with the 3n sequence, if I bring that up, if we have a look at the 3n sequence, which is 3 times 1, 3 times 2, 3 times 3, 3 times 4, that would simply give us the 3 times table. But the 3 times table goes up in 3s, it doesn't go down in 3s. So what do you think we need to do? The answer is we don't look at the 3n sequence, we have to look at the negative 3n sequence. Now, it sounds like it's going to be a bit more complicated, but I promise you, it's actually not too bad. We know what the 3n sequence looks like. The negative 3n sequence is exactly the same, but with negative signs. So minus 3 times 1, minus 3 times 2, minus 3 times 3, minus 3 times 4. We could say this is the minus 3 times table. And it's important we look at this because this sequence, unlike the 3n sequence, is actually going down in 3s. which is what our sequence does. So we're going down in threes, so I've written -3 as our gap. So -3n is going to be the sequence we focus on. And now let's compare it to the sequence that we want. So the sequence that we want, I'm going to write underneath. We have -1, -4, -7, -10. Let's compare these numbers to the ones that we have. Now, with negatives, needs to come a little bit more care. How do I get from these numbers to the numbers below? Well, if we look one at a time, how do I get from -3 to -1? It looks like I would have to take away 2. But if you think about a number line, so on a number line, you would have -3, you would have -2, you would have -1, you would have 0, and so on. If I started at -3, if I start at -3 and I want to move to -1, I actually have to go 2 places to the right, which means we have to add on 2. So to get from -3 to -1, we have to add 2. And that's the same for all of these numbers. Because we're deep in the negatives and we want to go lower in the negatives, that actually requires us to add on some numbers. So adding on 2 is how we're going to do that. So we started with the rule -3n, and then we need to add on 2 to our -3n sequence to get our sequence. So the rule for our sequence is going to be -3n, just as before, plus 2. And that is going to be our rule. Just as with the others, we're now going to find the 100th term. Now just be mindful, I'm just going to say at this point, you may be asked to find a different term, something like the 50th term or the 20th term. Whatever term you have to find, just remember, whatever that number is there, that's what we're going to replace n with. So here's our rule we've just worked out. We're going to replace n with 100. So -3, instead of times n, we're going to times 100. Then add 2. Right then, take your time with this one. -3 times 100, that would be -300. I'm just going to write my working out, -300. But I still need to add on an extra 2. Now, you might be very quick and say, well, that's just -302. But just be mindful, I'm very deep in the negatives here. By adding on 2, I shouldn't be going deeper into the negatives. I should be going towards the positive numbers. I would actually be decreasing through the negatives when I add on a number. So decreasing through the negatives by 2 places would give us -298. And that would be our 100th term. What does that mean? It means our sequence, -1, -4, -7, -10, if we keep on going, taking away 3, eventually we'll hit -298 in the 100th position. Here is your last task for the video. So pause the video and have a little go at finding the nth term and then the 100th term for each of these 4 sequences.